Good evening, everyone. Thank you all for coming out tonight, and thank you all for braving the weather. It's this is a something that Wesley was talking about earlier was one of the goals or missions of ETSA is the advancement of education, community practice, and support of IT professionals in East Tennessee. So that's something that could be learning, talking shop, talking, what's going on, could be, what opportunities are here in town, who's hiring, that type of thing. So it's always good to, share and to, if we can also learn what's the latest, greatest thing is. So it can help us with future opportunities. So I wanted to give a little plug out there for the organization. So tonight's topic is preparing for IPv6. During the mid-1990s, the internet really wasn't essential, right? It was more of a luxury item. I mean, fast forward to today, and everything that we do is involving the internet. I mean, it's in so many different manners. I mean, the thermostat, your phones, our jobs, right? I mean, you can't. I mean, think about going to the hospital, or your doctor's office, but when you think about how music media has changed, I remember finding 8-track cassettes, then 8-track tapes, and cassettes, and CD-ROMs, to MP3s. It's funny how vinyl keeps coming back, right? But with the internet, IPv4, it's been around for a really long time, and we've been using the same addressing system for a very long time. So this presentation is going to compare and contrast the differences between IPv4, IPv6, the history of how we got to IPv6, why we have it, and most importantly, how to prepare for it. These preparations will include the basic understanding of addressing, considering the application use, considering security. So, this will also conclude with many recommendations on best practices and things to consider. So, a little bit about myself. I've been in networking for probably 30 plus years. I started back in the early ISP days, back in the mid 1990s. So I had my hands in a little bit of systems, a little bit of networking, fun stuff. It's amazing how things has changed over the years. So we'll go into the There we go. So little disclaimers here. Talked about what we're going to cover, what we're not going to cover, tunnels, or application stuff, deep dives into specific protocols, anything like finite state machines, or, I don't want to put you all to sleep. If I wanted to do that, I would sit here and read RFCs to you, right? So I wanted to keep this fun, interesting, and also pertinent. I would have loved to talk about multicast, but that is such a topic that is that one kind of deserves its own topic, really does. But I'm going to gloss over and cover a little bit about the different types of communication methods. So IPv6, why do we have IPv6? Well, IPv4, they basically ran out of IP space 10, 12 years ago. They allocated the last major blocks, and there's not been any new IPv4 space. So there was this talk of, oh my gosh, the internet's going to come to an end. Not really. I mean, they did a couple things along the way to stave off that problem. And one of the things that they did, how we got to this problem, they used to have classful addressing. You had the Class A's, Class B's, Class C's, and those were just ginormous blocks. And they handed those out to like candy in the 80s and 90s. Between classful routing, like a lot of universities, major campuses, everything was on the public internet. I mean, they would have 64,000 addresses. I mean, some crazy number. And that was a lot of the original IP usage across. Then the ISPs came once the internet became commercialized, and that's when the IP, basically the whole world's IP basically started running into IP exhaustion. So when they saw this problem occurring, they said, you know what, we need to do something. The answer at that time was NAT, network address translation. If you think about this, when you look at your home internet connection, you will have, everything in your home is running, typically running behind some private IP space, like 192.168.0. something. And you're going to have a public address on your ISP connection, whether it's like a DSL modem or cable modem. That's your public address. All of your traffic goes to and from that one public IP. So let's think about this. What problems did NAT solve, and what problems did it create? So it's going to be fun. So with your typical home connection, let's say this is one end user here, and you have another end user over here, and this is a NAT type device. Well, if this laptop on this system wanted to talk to the laptop over here, if they all had public unique addresses, wouldn't it be great? It would just work, right? But you would have to basically, going out would not be a problem. There's different glue that you could do to tie this together. But for end to end, where the biggest problems, I mean, you can go through what's it called, like a application gateway, or some type of any type of gateway where you could do translation from one system to another to get around this. I mean, a lot of us have home camera systems, and you can access it on your phone, right? You're not going straight to the internet to your device. You're going through some person's website that your device is talking out to, right? So that's but NAT saved us from running out of IP spaces for our home networks. But for the end-to-end, let me give you an example here. This VoIP phone, when you pick up the phone and you make an outbound call to the PSTN, it's just going to work. It's going to create the set. Your router is going to create the session. It's going to hit your internet connection and go out to go reach across the internet to the public telephone network. Now, think about this from an inbound call perspective. Let's say that you haven't received a phone call in 30 minutes. Let's say that your device, NAT, basically uses these little pinholes where it keeps the session open. And it depends on your home router. That might be 30 seconds. It might be 1 minute. It might be probably no more than 5 or 10 minutes. So if you were expecting an important phone call and this router decided to close that pinhole, well, you wouldn't be able to get your phone call. So there has been entire industries geared around, how do we get around that? How do we solve this problem and they would basically throw expensive technology in the middle, where this device has to they have to intercommunicate every 30 seconds to keep this pinhole open. That's a kludge, but that's what they do in order for this to work. So there's so many workarounds, so many different things that had to be done. Let me give you another example here of what NAT would be. Let's say that you, back before the original IP-based cameras, how would you access that from the internet? Well, typically, I would say, I would open like port 5000 here, and I'd say forward to this internal IP here on port 80. Then I'd say port 5001, point it to this IP on port 80. And now, as long as I knew what my public IP was, I could go straight to my cameras. Again, it's you're having to have some kludgy technology there as a go-between. Wouldn't it be great if you could basically say, hey, this system, all these things are unique, and everything here is also reachable. That's kind of one of the goals of V6, and this is one of the underlying things. Now, let's talk about this. Everything with IPv4, everybody, it's a simple address, right? It's 4 bytes, 32 bits. And when you think about that, it's like, wow, okay, IPv6 is 128 bits. Like, okay. But when you think about the number of combinations, 2 to the 120th power, that's 334 undecillion addresses. That's a big number. That's huge. So I don't think we're ever going to run out of IPv6 addresses anytime soon. So let's talk about this. So IPv4, under the hood, everybody has ARP. ARP is basically a broadcast mechanism that allows you to map your MAC addresses to an IP address. In a nutshell, that's what it does. IPv6 doesn't use ARP. It uses multicast and it uses a protocol called neighbor detection. So IPv4, at one point in time, we had classful addressing. Then we went to classless. But we basically would have a CIDR block either way. But you also had the whole thing of subnets, right? I mean, you basically have to figure out, how do I carve this thing up? Do I take your common class C of this area right here? What you think about that? The common class C areas. Well, class C, 8 bits, right? You can only have 255, 255 numbers in that range, but you're going to lose a couple because of the basic concepts of networking. But with V6, you have 128 bits. So you have 64 bits that are allocated for your hosts. That is a pretty good number. Now you also have, so the first, I should say the last 64 bits. The first 64 bits basically is your network prefix and your subnet. So in theory, you could end up issuing a /64 to all of your networks, and you never have to subnet ever again. There's no more such thing as 255, blah. It's just /64. It's all you have to care about. So the loop back, everybody's familiar with 127.0.0.1 DNS records. I mean, it's just DNS is what DNS does. It resolves a name to a number, and we're really going to appreciate that with V6. So let's see. Let's see here. So there's some shorthand. The bottom of my screen here, I talk about the rhyme and reason here. It's like, so how do we make a number like 2001, 0 dB, lots of zeros, a 1, and lots of zeros? How do we make this more readable to human eyes? Now, let's talk a little bit about IPv6. I'm kind of jumping around here a little bit, but everything in IPv6 is hexadecimal. So basically you have 0 through 9, A is 10, B is 11, F is 15, right? So if you follow the pattern there. So you're rather than your typical base 10, how we've always looked at things like 255, 255, 255.0, we're now looking at basically 4 groups of we're basically looking at 8 groups of 4 characters. And these are hexadecimal characters. Now, that is a really big number. So there's a methodology of shorthanding this. Each one of these is separated by a colon. So first of all, you can do 0 compression. So if you have a leading 0, drop it. If you have, so the 0 compression already makes it much easier to read. But if you have contiguous groups of zeros, you can also use : to basically denote, hey, I've got a bunch of zeros here, but you could only do it once. You cannot. So you could in this instance right here, you could either do 2001 : db8 : and that would imply all the zeros there, or you could put it on the other side, but you cannot have 2 sets of colons. So that shorthand, it's kind of handy. Well, let's reflect on this for a minute. We've gone from 4 simple, easy to remember numbers to this gigantic string of hexadecimal characters. I can still remember 204.117.214.10. It's carved into my brain. That's the first DNS server I ever configured. 206.230, 102.5. You remember these addresses. I'm not going to remember 2001 : ABCD : 54AF : 1 : some big number, right? Think about this from a tech support perspective. If you're calling in and saying, hey, I have to configure some stuff on my network. Can you imagine? I mean, it's a lot easier to say, yeah, 255.255.255. Can you imagine reading that to someone over the phone and having to read it back?
Well, no one knows NATO is the problem.
That's a whole other problem too, right there, but it's, there, you also have to think about it from, I mean, there's a lot of room for error. And one of the things that, since you can use shorthand, you also have to think about, well, what if they use lowercase letters? What if they use a combination of upper and lowercase? Still valid, right? I mean, you have to think about if you're doing any type of tool development, you want to make sure that you can look at basically be able to do you're not, if you grep for 2001 colon ABC, you want to make sure, it might be lowercase ABC, but if your grep isn't different, if it's case sensitive, you're not going to find what you're looking for. So those are some things to kind of keep in the back of your mind. So unspecified, colon, that's basically means you don't have an address and you're getting ready to request one. Loop back at your local address, pretty straightforward. It's your 127.0.0.1. Multicast, that's your multicast range. Link local. Now that one is special, and we're going to go into more detail. I want to focus primarily on link local and global unicast. Site local is basically your equivalent of RFC 1918. So you can actually have unrouted IP addresses that would not route across the internet like you would need, I mean, not that you would need, I mean, it's another way to guarantee that if you needed space that was for security reasons, you truly wanted something that was unreachable, yeah, you could do that. So
That like your 192.168.
yeah, absolutely.
Private IP or blocks.
Are just the exact same thing. So the let's think about this here for a second. IPv4 has been around for a long time. V6 has been out for a very long time, but since they're not handing out any new V4 IP space, there's going to become a time and place where some customer may only be V6 only, or you end up with some device that has V6 only. This actually happened to me once. I actually had a device that was IPv6 only. So it's coming, right?
Like an internal or like a user?
I'd have to talk about that outside of this, but it's a special case.
So one question for me.
Sure.
On here. So it's not local. I like the 1918 comparison there. To my current knowledge, IPv6 has zero concept of that.
You can still do it though.
Okay. So in the event that you were using site local, your router could NAT it down.
Absolutely.
Okay, so you're not pigeonholed if you said,
Nope, not
if
all.
a security guy says, oh, I'm gonna do this, it's like, well, no.
There's many ways that you can do this, right? I mean, back before there was even such a thing as RFC 19, I used to route public IP addresses to my modem and have public IP addresses on all the devices in my house.
Just
And
go to UTK, they still do that.
But I controlled all my I controlled all that on my router. So I had complete control, but I also had end-to-end reachability. It was great. So life was good then, minus the speeds. Speeds sucked. But so let's talk about link local, and we're going to go more in depth. I have a couple screen captures, but in essence, what a link local does is it basically converts your MAC address into what's called a EUI 64. It's a extended unique identifier. You need the link local. Link local is part of your mechanism for how you obtain an address, whether it is stateless auto configuration or if you're using DHCP. There are some things under the hood that basically allow you to. V6 does some cool things. It looks for duplicate address detection. It does that with link local. It's like, hey, anybody using? I mean, I'm getting ready to use this. Is anybody using this? The Slack, the stateless auto configuration. Depending on your environment, it's great. The network is just going to work. No DHCP server involved. Everything on your home, everything in this network is just going to work. If you're in a secure environment, you may want to have, or you have an environment where you care about controlling the addresses and what systems will have access to what. Probably want to turn that off. We're going to talk about that too. But anyways, back to link local. Yeah, following this mechanism here, it's like, okay, you've got this MAC address 112233445566. in essence, you convert the first octet to binary, you invert the 7th bit, you convert that back to hex, you add an you add an FE in the middle, then you prepend it with an FAE0. I'm sorry, FE80. Yes, it's been a long day. And or use a calculator, right? I mean, the whole purpose of this is if you're going to DHCP, you want to know what the MAC address of the device is, so you can know what that is. And and when you start seeing your DHCP requests, you're going to have to look at the EUI information in a nutshell. So let's talk about some things here. Know your infrastructure. Specifically, you want to think about your application needs, the business cases, and your security policies, right? Do you want things to, you may not want the same devices that is in accounting to be in the same network as the people who are doing repairs, right? You may want to have some, you may want to have some different IP space, or even better, different layer 3 boundaries. But one of the things I would recommend is getting all of your different teams on board and at the same pace together. The reason I say that is if one team is leading the charge, let's say, or this one's like whether the security or that's the server team or the network team, if one team is taking the charge, that's the team that's going to get the crap beat out of them because they're having to either have to drag everybody else, or if everybody's in tune together, everybody is on the same page together. Everybody has, we know that we have the correct security policies. We know this matches the server team. The networking team everybody has the same requirements and they know what's going on. If you end up having a mismatch, it can be a very vicious cycle where one team is having to carry all the other teams. So some of the things I personally would recommend is lots of IPv6 training to figure out what's going on and just to have a basic understanding of how do you use it. And I'm going to go over some of this, how you can turn it on in your house, how you can just kind of play around with it. But setting up a test lab is huge. Figuring out how do you disable Slack? How do I hand an address to an IPv6 address to a group of servers? Do I care to do that on a per MAC address? Do I just want to have a generic pool where anything can access it? Or do I want to have do I want to assign, hey, this MAC address, this link local goes to this IP, this link local goes to that IP. It all goes back to knowing what your requirements are, what your security, and everybody has to be in lock and step together. But you want to start with the foundational stuff. You want to think about DHCP. You want to think about DNS. You do not want to have to hard code these numbers. I mean, it's easy enough to mentally flip them, much less type them all the time. You want to play around. Some things I will be the first to admit kind of blew my mind with V6. Router advertisements. That one just blew. Everybody knows what your default gateway is, right? It's the system that if you don't know the local LAN. Well, imagine if you had a host on your network that says, hey guys, I'm your gateway. You send all your traffic to me, wink, wink. Mm-hmm. Yeah, what could possibly go wrong here, right? it has some interesting load balancing things that you could do.
On the default gateway?
Yeah, if you had another system that's like, hey, if you had multiple places saying you could actually do some creative. I'm guessing that's what they had in mind. But how often have you been in an environment where somebody took the IP address of the gateway and nothing was working? So yeah, there's some interesting things that you basically want to figure out what works best in your environment and have some best practices and some templates. And we're going to talk about that. Your typical home network, there you go, it's disabled. I thought that was kind of interesting.
Do you actually run a TP link at your house?
In one of my 6 access points, yes, I do. So I was playing around with IPv6 in an IPv4. I'm not showing any of the v4 information here, but I found this interesting that I have these two IPv6 addresses. Now notice these are link local. And if I look at the neighbor table, it's empty. But how about that? From server B, I can ping server A over IPv6. V4, but here's the thing, V6 is disabled, but yet two hosts can communicate to each other on IPv6. They're in the same broadcast domain. Now, when I did that, I was able to look at the IPv6 neighbor show. Hey, there they are. And this is what really blew my mind. When I SSH'd to that linked local address, a lot of your listeners are listening on V4 and V6. So you may be, from a security perspective, you might like, wow, I had V6 running on my network and I didn't even know it. Right?
What's with the bond 0?
That's just the interface. So you have to specify, if that would have been, the device name in Linux, you have to specify, if that would have been like E5 right here.
Yeah.
You have to, if you're doing something over the link local, you have to add the interface, %bond interface. It's different in Windows. I unfortunately didn't grab the Windows command.
That's interesting because like it's all based upon MAC address there. So like each interface would have a different MAC. So
And these are unique addresses. So they're different, they're unique local, right? So the unique local in one can reach the unique local in the other, even though you don't
But
have
what
a
about
V6.
like Windows to Linux? That's like, would Windows still have to do ping IPv6
Oh.
at bond 0?
Actually, you don't have to do that in Windows. I didn't capture that here, but I did test that in my home network, and you'll see
Okay.
I shifted over to Windows, but I didn't capture the neighbor detection. I thought I had captured that in my yeah, I was putting together a bunch of different screen caps, but
Okay.
so yeah, I enabled IPv6. I turned on DHCP, and what's really cool, 30 seconds after I did that, I looked at my phone, and on the internet symbol, it had a 6 under it. My phone was immediately using V6. I'm like, that's pretty cool. So I immediately, first thing I did is like, okay, well, let's do ping6 google.com. Boom. And then I ping google.com. I was like, wait a second, I didn't specify V4 or V6. How about that? It defaulted to the V6. It's like,
Yes, we've had problems with that at work because it defaulted to 6 and broke the 4 for
Mhm.
DNS lookups.
So we're going to talk about that here in a minute too. So you can ping V4, you can ping V6. At this point, this system is acting as what's called a dual stack environment, which I thought that was pretty interesting. Like I said, I had another screen capture here, and I did not include it, but I thought it was interesting how Comcast was actually handling their how they were handling their DNS servers. I thought that was 2001-558 feed 1. Oh, wait, yeah, with hexadecimal, you can also do some cool naming systems. I've seen bad beef, dead something, you can be very creative and if you, yeah. So single stack or dual stack. We've all been single stack for 30 years, but what can go wrong? Let's say DHCP is down or DNS is down. Look at Netflix.com, right? You really have to, when you do an NS lookup of Netflix, it's showing both the V4 and V6 addresses. Your applications, there is no rule, so there's no rule that some applications can have it hard coded, and it will try V6 first always, or it may try V4 and then try V6 as a failover, but some applications, that's something that you can tune and say, I want to be V6 only, or I want to be V4 only, or you could set the order of operations. It depends upon the application. But if you have a problem where something in V6 is not working, but your V4 stuff is, now rather than having to troubleshoot one network, you're having to troubleshoot two across the same path. So yeah, it's the reachability issues. It's like, and it's also the timing, like how many times will it try before it fails over? So there's going to be some interesting learning things. Now, as soon as I did an experiment, I turned on a TCP dump on my V6, and I basically did a capture of all my traffic for a week. And I looked at my V6 traffic, and I looked at my V4 traffic. My V4 traffic, someone knocked on my front door 100 times a day. Someone was looking for SSH for 80, they were looking for ports. My V6 side was silent. Nothing, not a single, only traffic that I saw was the traffic coming back to me. We'll talk about that here in a minute, but some people think that V6 is secure. Yes and no, and we'll talk about that in a minute as well. But let's go back to the whole scanning thing. You know, in V4, I could scan the whole internet fairly quickly, right? You can fire up Nmap, and you can have a lot of really ticked off people that you're banging on ports on all their servers. But for V6, due to the size of that number, you're not going to be able to scan that in any time. I mean, it's going to take millions of years. It's just not possible. Now you can do some creative things in your organization. You can say, hey, although I have this /64 subnet, I only want to use the first 1024 addresses. So you can specify the size of the pool. You don't have to give it the full range. And we'll talk more about that here in a minute. But you could say some sane size, like, hey, I only want 4,000 computers in this network. Oh, darn, right? You don't need, that many numbers. It's just not possible. But so that's for the systems that manage about. What if your security team says, hey, I want to know what devices are outside of this range? We have a compliance requirement that says we have to scan this entire network. Well, there's ways that you can get that. So you can use SNMP data and scrape the V6 neighbor table from all the network gear. Or you can put a security host in the broadcast domain of every single network. Or you can put strategic taps at different points so you can look for any type of neighbor detection traffic. So there's many ways that you can gather that data to give an idea of what's going on in your network. So back to a little more on the security side. When I was talking about router advertisements, what system can become the gateway? Well, for starters, you want to find out, do you want this stateless auto configuration to work or not? Or do you want it to be disabled? You also want to figure out, okay, well, do we want a system to say, hey, everybody on the network, I am now your gateway? Probably want to disable that stuff. So there's things that you can do in Windows. There's things that you can also do in Linux. I just showed what was on the Linux side. But there's also things that you can do on the network gear that basically, even if someone does turn on router advertisements, it's going to disable. It won't forward those on. So there's a command in the gear called suppress router advertisements. So as you test V6, you may want to verify, do these functions actually work? V6, definitely not easy on the eyes. It's easy to make mistakes. Heck, I could read it here and give it to you backwards, but I think that's probably because I'm doing this. But it's a good case for having templates, and it's also a very good case for basically using some form of automation to keep consistency. A lot of your firewalls support FQDN. Basically, rather than saying, hey, I'm using DHCP1 and it gives this address, the firewall would actually resolve DHCP dot whatever your organization is and then keep that address. You have to be careful if you use FQDNs on your firewall because you can create a circular dependency. Let's say that someone goes in and kills the EPO button and your whole data center goes down. Well, let's say your firewall comes up, it lost its cache. It now no longer knows how to reach these servers. How can it forward traffic if you don't have that information? So if you were to use FQDN, you would want to selectively say, what's the most important stuff do I need to have hard-coded to have functionality? Otherwise, things will just die. So something to also think about with your tools. I'm glad I printed this, otherwise I'd be breaking my neck. So IPv6 subnets and planning. I found this interesting. Aaron, they're basically recommending anywhere between a /48 to a /56 for end users. So when you think about that, that's like, they're saying they're saying a /48 for a single site, and If you have multiple sites, you can even go with larger, but let's do a deeper dive into what that actually means, right? So if you take a slide, if you just do basic, hey, if you think about like your class C and you start saying, hey, what's a /20, how many /24s are in a /23? 2. Well, same thing applies here. It's all about powers of 2. If you have a /64, if you have a /63, that's 2 /64s. If you have a /62, that's 4 /64s. Fast forward on down a few more bits. /48 is 64K worth of /64s. How many people have 65,536 networks built in their network? Okay.
Probably just Amazon, Google, and AWS.
But if you're using commodity hardware, and we'll talk about that here in a minute, this is where we're going to start talking about the V6 reality. Actually the last item here, right? Your network gear is limited in number of VLANs. You can only configure 4,000 VLANs on a switch. That's it. Now you can do some crafty things, and you can do stuff like VXLAN, where you can map VLANs to what's called a VNI, and you can get 16 million. But you're still limited to the 4K VLANs. That's it. Your MAC address table. Your typical switch in your house is probably only capable of like some power of 2 really low, like maybe 1,000 MAC addresses or 4,000 MAC addresses. Some of your more enterprise gear can go up to 16,000 or 512,000 MAC addresses. Nothing can handle 2 to the 64th power of hosts. It's just not possible. From a security perspective, so no one knew what my public addresses were. But if I was a hacker, hey, if I want to find out who's using V6, I'm going to go out and hit. If I'm going to find me a DNS or web server, let's scrape what addresses are actually being used. That way, you now know what you can attack, rather than just banging on each one and hoping and coming back in a few million years. Now you're going to know what's out there. So yeah, those are. Is it security through obscurity? I mean, when I was talking about those daily denies, right? I mean, it was just amazing. It's like, there's nobody knocking on my front door. I mean, if I go to work, someone knocks on my front door 1 million times a day on a slow day. But early on in V6, you basically had the network gear. It did V6 in the CPU. And that's great for small devices. But if you were talking about something that would perform, it basically did not hit the ASIC, and there was performance issues. V6 still is not heavily used. I was looking at the the V6 adoption rate. Cloudflare and Google has some really interesting statistics on how heavily V6 is. I was kind of surprised, but yeah, V6 is, I don't think it's going to go, it's not going to go away. The thing is, we have to know where there are going to be cases where we might have so let's say someone in your organization has a need to access a resource that's only V6 only, or you get some new device that is V6 only, those are the main cases. I mean, now there are devices that you could basically tunnel. You can basically, there's mechanisms out there. You can get by with I don't foresee V4 going away anytime soon. I know people were early on, people were saying this is the death of V4, V6 is just going to take over. But the reality is, there's so much IPv4 space that's still unused. There's a lot of places that have held on to that because it's money, it's a commodity. There's a lot of old ISPs out there still holding on to, even universities, holding on to IP space because they think it's a gold mine. And they're selling it, right? They're reclaiming the space. But between that address space being available and NAT, and a lot of carriers are also, I mean, let's face it. If they were doing natting for you and didn't actually give you a public address, would you even know it?
Yes.
Not everybody.
Most people know.
Most people wouldn't.
Most of us in the room, yes.
Depends on the person, right?
What something I just wanted to mention, where you're talking about like CGNAT and stuff, so. A lot of like traditional rate limiting stuff is still set just on IP, and something we noticed a lot was people in developing countries, they constantly get rate limited because of CGNAT. It's just kind of an odd thing. Keep in mind, this was on streaming, but
A lot of the quality of service has been geared towards IPv4. And I've noticed that when I would shift over to V6 only, sometimes I might get faster throughput. And it's kind of like, think of it in a difference. You might be using kind of like a VPN, might be going through a different path.
I just realized there's quite a few chats there. We completely forgot to log in, so I think people have questions.
Oh, no, I'm sorry.
I do know we're gonna be in DC. I was told last year you have 5 years to be 6 compliant.
Yep.
All the way across. No more.
That's for who?
Beneficiary company in DC that gets government funding.
The government is also pushing that very heavily. It's a modernization effort, right?
Yeah.
Future proofing, a lot of things, there's got these milestones where you have to meet X amount of devices that can support either dual stack or V6 only. It depends on your environment. I mean, some cases it makes sense. I mean, at work, I don't have enough public IPs to put on my supercomputers, right? I don't. I have to use private IP spaces on these things. It'd be nice. I mean, for V6, yeah, that's the right answer, right? But for V4, I don't have the space.
Forgive me if this is a really ignorant question, but why is there like a negative of going from V4 to V6? Why wouldn't we want to do that if there's so much more space?
So a lot of it's fear. You may find out that it's a scary thing. Sometimes it's a security. If people don't know how to secure it or how to block it, right? Like for NAT, for example, no one's going to reach your home computer through that NAT unless there's a pinhole open. Now, if you have something that's publicly routing to you right straight to your home computers, if you don't have a firewall that's blocking that traffic, someone could basically be knocking on your PC's front door instead of your router's front door. So there's security implications there. V6, a lot of device, not very many people use V6, so there's going to be bugs. The more eyes that are on it, the better it will be. Now, the growth of V6, the past since like 2016 to now, it's been growing probably, I can't remember the number. Looking at the graph, it was impressive. It kind of reminded me of the mid-90s.
Why do government entities want to push for it if it's risky?
So that's a very good question.
They're
So-
usually not up for that.
You're correct. It's also future-proofing your networks. If you do it and do it correctly and do all the best practices, you can do it in a very good way.
And you're
It's just,
ahead of the game.
it's. When I was talking about the organizational where different parts of the company, everybody has to be in lockstep together. It's not a priority for people. If V4 works, why bother? If we got these 20 other fire drills, but yet this is a mandate, it's like, where do you draw that line, right? That's a political question. And you can only dodge that for so long before you end up with that device that lands on your doorstep that says, yeah, this is V6 only, make it work.
Yeah.
Humans are reluctant to change, big thing right there.
True.
We're reluctant to change. Management is reluctant to ever spend money they don't have to. There's the bigger problem.
There's time, there's money, there's documentation, there's,
Well, so sorry to cut you off here, but one thing I wanted to say is, so like, just at my house, I have Frontier Fiber. I don't get V6 as an option. I can't do it back effectively.
you can use a carrier like a Hurricane Electric.
Yeah, it's slow as hell.
It is, absolutely.
Yeah, it
But-
does not benefit me.
If you wanted to play around with the services, you could, right? I mean, that would be the only, if you wanted to have something routable. But yeah, I agree. Yeah, HE was definitely slow as mud, but it was something for proof of concept, right?
Yeah, no, I mean, I used to use it, and I think like Aaron was talking about, he uses the HE64. I think my PFSense router still has a 6-to-4 tunnel on it. I just don't use it.
Yeah. Tunneling mechanisms is also something that I didn't really want to talk about because that could be a huge rabbit hole
Yep.
of time. but there's other mechanisms that could, shall we say, your security policies that you want to make sure of that, there's stuff that could be happening that you're not even aware of it.
And Grok, but in IPv6.
Interesting.
I was making a
Oh.
horrible joke.
Oh, gotcha. Okay. It's like,
The reverse like HTTP proxy solution for NAT-based networks.
Hmm.
Or maybe it's just Grok or something.
yeah. End-to-end reachability. I mean, it does solve some problems, but also create some new ones. So yeah, it's personally, I mean, I think it's at least good to know what to look for and to start playing around with. It's like I said, I don't think it's going to go away anytime soon. And different organizations, you might find you have a use case for it next week. You never know. So
I think a lot of it has to do with the fact that a lot of companies are using older equipment that don't recognize 6.
that is a part of it. Some places I've seen some really elaborate schemas of, hey, we're going to move over to this V6 space and we're going to say this block goes to that building, this block goes to that building, this block goes to that building, and things change, right? I saw one person do another map of, they were basically mapping all of our V4 to all V6. Great. Now, but that required us going to /65/66 is going the other way. So we were basically subnetting V6, and you can do it. You're not supposed
Yeah,
to. Not
because it breaks all the auto configuration.
right. Oh darn. But that is it in a nutshell. I tried to keep it below 8 o'clock. Let me check questions here. And folks on Zoom, I apologize. I did not. Yeah, so most links still don't require the explicit images if you use, okay.
Oh.
Passive DNS brokers have terrifying amount of yeah,
Most fun, guys. I put in a lot of not questions.
gotcha.
What was the KUB one? DS what?
Dual stack light is slang for V6 with CGNAT at D4.
No, Brandon that goes to this group, he's got KUB fiber and he straight up had a public before, which was surprising because when I talked to them on their implementation plans, they were talking of doing CGNAT.
Okay, so maybe something's changed in
Yeah.
the interim.
Carrier grade NAT basically means you're not going to have that public address to your home device
Double
anymore.
that.
And it's not usually full cone, so it means that things like games get unhappy because they expect to be able to use techniques like UDP hole punching, which doesn't work with CGNAT.
At that point, you just want to move everything over to V6, right? I think that's
I
really.
mean, the game folks would like it because path-specific MTU actually working on the public internet would be great.
That's a concept I've never heard. That sounds interesting.
Let me go ahead and turn off the stop share. Was there any recording?
I guess I was mentioning when the gal whose name I didn't catch was mentioning that, direct accessibility becomes